Next practice problem. Determine the slack times for the following AOA activity on arrows diagram. Identify the activities that are on the critical path. So you first need to find the critical path and then identify the critical activities on those paths. So please pause here, try to solve this problem, identify the paths and find the critical path, and also compute the slacks. One way to find the critical path is to list all the passes, and the critical path would be the lengthiest path, the path with the largest length. So let's go ahead and list all the possible paths. So we're going to start from the beginning and identify all the passes. So one pass is 1 to 2, 2 to 5, 1 to 2, 2 to 5. And the length of this pass is 4 plus 6, 4 plus 6, and that's 10. Length path. Let's find other paths here. Another path is 1 to 2, 2 to 4, 4 to 5. 1 to 2 to 4 to 5. The length of this path is 4 plus 2 plus 3. So that's 9. Another path here is 1 to 3, 3 to 4, 4 to 5. So that's 1 to 3 to 4 to 5. So that's 9 plus 5, 14 plus 3, 17. Seventeen is the largest length here, so that means that 1 to 3, 3 to 4, 4 to 5 is the critical path, and the length of the project would be 17 as well. Now let's go ahead and find the slacks. To find the slacks, we're going to have to find the earliest start, early finish, latest start, and late finish. So I'm going to identify for every activity. Let's actually draw this box here. So for activity 1 to 2, let's find the earliest start, early finish. So we compute the earliest start, early finish beginning from the earliest point, the start point, which is node 1, and we go through a forward pass up to when we get to the last point, and we compute the early start and early finish. The early finish formula, after computing and identify the earliest start, is earliest start plus t, and t is the time that it takes to complete an activity. So for activity 1 to 2, the earliest start is, you can start as time 0, and the early finish is earliest start, which is 0 plus t. T is 4 here, so 0 plus 4 is 4. So the early finish is 4. Now let's move on to the next activity. Activity 1 to 3. I'm going to draw this little box here. So activity 1 to 3 can start at time 0, and the length of the activity is 9. So the early finish would be 0 plus 9, which is 9. Let's move on to the next activity. Activity 2 to 5. The early start of activity 2 to 5, because it depends on the activity 1 to 2 to be completed, so it needs to wait until it is completed. So that's 4. So the early start of activity 2 to 5 is 4. And the early finish is early start 4 plus 6 the time t. So that's 4 plus 6 is 10. So the early finish is 10. Now let's move on to the next activity, activity 3 to 4. I'm going to draw the box here. The earliest start of activity 3 to 4 should be after activity, the previous activity, the predecessor activity, which is 1 to 3, to be done. And the earliest time that activity 1 to 3 is done is 9. So that means that activity 1 to 3 dictates the earliest start of activity 3 to 4, and that's 9. And the early finish of activity 3 to 4 is 9 plus 5, so that's 14. Now let's move on to the next activity, activity 2 to 4. Activity 2 to 4 needs to wait until the predecessor activity, which is 1 to 2, to be completed. And the activity 1 to 2 is completed until 4. So the earliest start for activity 2 to 4 is 4. And the earliest finish is 4 plus 2, that's 6. Now let's move on to the next activity, which is activity 4 to 5. The earliest activities of 4 to 5 should be after all the predecessors activities to 4 to 5 are done. And that means activity 3 to 4 is completed and activity 2 to 4 is completed. Activity 3 to 4 is completed by 14 and activity 2 to 4 is completed by 6. So the earliest start point for activity 4 to 5 is the maximum of the early finish of 14, which is 14, and 6, which is 14. So the earliest start of activity 4 to 5 is 14. And the early finish would be 14 plus 3, so that's 17. Right, so we could actually add a dummy end node here and a dummy activity here. The length of the activity would be 0. So 5 to 0, that means the earliest start point for 5 to end is the maximum of 10 and 17. So that would be 17. Anyway, without even drawing the dummy 5 to end node, we can also do that. So let's actually get rid of this. And let's compute the latest start and late finish. So for latest start and late finish, we start from the end. So we start from end and move backward until we get to the beginning point. So let's start for the activity 4 to 5, for example. Activity 4 to 5, the late finish is equal to the early finish. So the early finish is 17. So the late finish should be also 17 because we do not want to delay the project. So we want to the project get done by the 17, by the length of the project. So the latest finish that this activity can be completed without delaying the project is 17, equal to the early finish because it's a critical activity. And to compute the latest start, we can use this formula. Latest start is equal to the late finish minus t, and t is the activity's length. So the late start for activity 4 to 5 is the late finish, which is 17, minus t, which is 3. So that's 17 minus 3, that's 13. That's 14. 14. Right, now let's move on to the parallel activity, activity 2 to 5. So the latest finish for activity 2 to 5 is 17 because that's equal to the length of the project. That's equal to the length of the project. So activity 2 to 5 has a late finish greater than its early finish. To compute the late start, we're going to use the formula. So late start for activity 2 to 5 is late finish, which is 17, minus t, which is 6. 17 minus 6, that's 11. So the late start for activity 2 to 5 is 11. Let's move on to the next activity, activity 2 to 4. The latest finish for activity 2 to 4 is equal to the late start of the next activity. So that's 14. And the late start would be using the formula 14 minus t, so 14 minus 2, that's 12. Now let's move on to the next activity, activity 3 to 4. The late finish of activity 3 to 4 cannot be more than or longer than the late start of 4 to 5. So this means that the late finish of 3 to 4 is 14. The late start using the formula is the late finish, which is 14, minus t, which is 5. So that's 14 minus 5, which is 9. The late finish for activity 1 to 3 is equal to the late start of the next activity. So that's equal to 9. And the late start would be using the formula 9 minus t, which is 9 minus 9, that's 0. Next activity is 1 to 2. The latest finish of activity 1 to 2, because there are two activities that are after 1 to 2. So that means 1 to 2 cannot finish before the smallest late start of the next activities. So that means the smallest of latest start of 2 to 5, which is 11, and the smallest and the latest start of 2 to 4, which is 12. So both activity 2 to 5 and 2 to 4 cannot start later than the finish time or the latest finish time of 1 to 2. So this means that the late finish of activity 1 to 2 is equal to the minimum late start of activity 2 to 5 and the late start of activity 2 to 4. So that's the minimum of, this is 11 and this is 12. Minimum of 11 and 12, that's 11. So the late finish of activity 1 to 2 is 11. The late start would be 11 minus 4, so that's equal to 7 here. So we have computed all the early start, early finish, late start, and late finish. Now we can compute the slacks. Okay, so for activity 1 to 2, the slack actually is equal to late start minus early start, or late finish minus early finish. So for activity 1 to 2, the late start is 7 and the late and early start is 0. So that means the slack for this is 7. Or we could do it by late finish and early finish. So the late finish is 11 minus the early finish, which is 4. 11 minus 4, that's 7. Still 7. Let's go to the next activity, activity 2 to 5. Activity 2 to 5, the latest start is 11. The earliest start is 14. So this means 11 minus 4, that's 7. Or we could do it with late finish and early finish, which is 17 minus 10, again 7. Next activity, activity 2 to 4. 2 to 4, the late start is 12, the earliest start is 4. So the slack is 12 minus 4, 8. Or it could be late finish and early finish, that's 14 minus 6, that's still 8. Next activity, activity 1 to 3. So for 1 to 3, the late start is 0 and the earliest start is 0. So that means that there is no slack, and it makes sense because 1 to 3 and 3 to 4, 4 to 5, that's the critical path. So 1 to 3 is a critical activity, so there is no time to spare. There is 0 slack. Or we could do it by late finish and early finish, which is 9 minus 9, that's still 0. Next activity is 3 to 4. That's again on the critical path, so we can actually expect that the slack is 0, and you can check that by computing the slack. The slack is late start, which is 9, minus early start, which is 9, which is 0. Or late finish, 14, minus early finish, which is 14, again 0. Next activity. Activity 4 to 5. For 4 to 5, the late start is 14. The earliest start is 14. So the slack is 14 minus 14, 0. And it makes sense because 4 to 5 is also on the critical path. The critical path is 1 to 3, 3 to 4, and 4 to 5. So the slack for 4 to 5 is also 0. So now we have computed all the slacks here. This is a printout, typed out version of the final solution. So as you can see here, we have computed all the earliest start, latest start, early finish, and late finish here, and also the slacks for all the activities that we have. And as you can see here, the slacks for the critical activities are 0 because the critical activity or the critical path is 1 to 3, 3 to 4, 4 to 5, and the length of the project is 17. So this means that actually we can delay the activity 1 to 2 individually by 7, 2 to 5 by 7, 2 to 4 by 8. These are individually. So when you want to apply this is going to be different because you cannot delay all the activities on a path by its slack, because when you actually compute the slack, it's based on the assumption that all the activities start with no hesitation, with no delay in the previous or the after activities. So you have to be careful when you want to apply the slacks. We compute the slacks individually and in isolation for each activity, but when you want to apply it, you have to be careful of the predecessor and also what comes after the activity that you want to delay.